Hello everyone. Welcome to your first Unit 1 practice exam video. Today we're looking at our version number 1. And so just a quick recap of how the exam works. Everything on page 1 or anything under part 1 is typically going to be worth 2 points each and no partial credit will be given. But if you ever see a star next to a certain question, like let's say for example for number 3 and number 4, those are questions that you have to show work for in order to earn full credit. And yeah, let's begin. Okay. So looking at number 1, they ask us to circle each statement that is true. So this question is an all or nothing. You either get all of it right, or even if it's one thing that is wrong, you get the whole question wrong. So we have when the function f of x equals x squared is multiplied by the value a, where 0 is less than absolute value of a less than 1, the graph of the new function g of x equals parentheses a times x to the power of 2 is a result of a horizontal shrink of f of x by a scale factor of a. So over here what we have to analyze is, well, we know that the function has a value of a that's being multiplied, but specifically we can see that because it's within the parentheses, it's going to be affecting our inputs, or in other words, our x values. So if a transformation is going to affect our x values, we know for sure it's going to be a horizontal change. So that part is okay so far. Now, they tell us that the value of a, or specifically the absolute value of a, because right now what we're doing is ignoring reflections. So if we have some sort of value that's between 0 and 1, then for sure that's going to be something like, let's say, half, well, just anything less than 1 that's still positive. And so that in case, well, if we're affecting the x values, we know for sure we can't trust an x. So therefore, it's no longer going to be a shrink, but rather instead a stretch. And so that's the first thing that's wrong with this statement. And so when we have a horizontal stretch or shrink, regardless of if it's stretch or shrink, the scale factor that which we apply to is not going to be a itself, but rather always going to be the reciprocal, 1 over a. So this guy right here is also problematic. Let's look at number 2. We have the domain of the function f of x equals square root of x plus m is bracket negative m comma infinity parentheses when m is greater than 0. So let's just first understand what this is even saying. So we have some random square root function, and then they also tell us m is greater than 0. So if m is greater than 0, that tells us that m itself is positive. So right now what we know for sure is that we're going to have a square root function, but if m is positive, we know for sure that it's going to be a shift to the left by m units. Hence why we have negative m towards infinity forever and ever, since we're talking about domain here. So this in fact is indeed true. Number 2 is true. Alright, let's look at number 3. So in a system of linear equations of 2 variables, if 2 lines have the same slope, then it indicates that there exists no solution. So we know for sure that no solutions looks like when we have 2 lines that are parallel to each other. And so from here we got to think, well, what do we know is objectively true? We know that the slopes are the same, yes, but the y-intercepts must be different. And nowhere in this problem did it tell us any information about the y-intercept. So even though same slope is correct, they didn't give us enough info, because the question becomes, well, what about the y-intercept? Because the moment that the y-intercepts become the same, then therefore that is infinite solutions and not no solutions. Let's look at number 4. We have, given a negative correlation coefficient, we can say that as the x values increase, the y values decrease. So we just have to remember that a negative correlation coefficient just tells us the direction of the line of best fit, or in other words, it has a negative slope. So I'm just going to draw a random line as such. Now over here, unlike what we're usually used to, which is talking about as the x values increase, well, it doesn't matter. Let's just interpret what this is even saying. So as the x values decrease, we can see, yes, indeed, the y values do increase. That's what matters the most. So number 4 is also true. So when it comes to negative correlations, As long as the relationship between the x and y values, as long as the relationship between the x and y values are different, or in other words, one increases and the other decreases, then that's perfectly fine. So that concludes number 1. Let's look at number 2. A company that features toys first pays a startup cost. That's important information. So the moment that we see like a startup cost, what that implies is that's going to be our y-intercept. And then spends a certain amount of money to manufacture each toy. So because we know that it's money per toy, that's going to be our slope, whatever that is. And then they tell us that the total cost of manufacturing toys can be modeled by C of t equals 5.25t plus 125. So what does that even mean? So we know that the total cost of manufacturing the toys is going to be C of t itself, since that is our output. And so like we said before, the startup cost, that is going to be our y-intercept, the constant that has no variable affecting it, and then spending a certain amount of money to manufacture each toy, that's going to be our slope, in other words, 5.25. So now let's answer the question. Circle each statement that is true regarding this function. So once again, we got to circle all the correct answers. If one of them is wrong, the whole question is wrong. So let's see. Number 1, the startup cost is 125. Yup, exactly what we said. That is a one-time fee that doesn't need to be paid multiple times. Number 2, the profit earned from the scale. The profit earned from the sale of one toy is $5.25. $5.25. So, well, let's see. We said that the amount of money spent to manufacture each toy is 5.25. So it costs the company $5.25 to make the toy. Nowhere in the problem does it even talk about making money or profit. So number 2, bad. Number 3, that's pretty straightforward, like we said before. The amount of money spent to manufacture each toy is $5.25. So once again, just to break down this equation, let's see. So T in this case represents toys because C of T represents the total cost of manufacturing the toys. So the total cost in which it costs the company to make these T toys, they first have to pay a startup cost of $125, and then for each toy that they make, they have to pay $5.25 to make. So adding those two values all together will give us the final cost to the company for manufacturing T toys. Okay, number 4, just based on what we talked about before, yes, indeed, that is true. T represents the number of toys, since that is being multiplied by our slope. Then we have 5.25T represents the amount of money spent to manufacture T number of toys. That is also true, because if we know it costs $5.25 to manufacture one toy, then to manufacture T toys, T number of toys, we multiply them together to get the final cost. And once again for number 6, here they tell us that 5.25T represents the profit earned from the sale of T number of toys. Once again, nowhere in the problem does it talk about making money or profit earned, anything like that. So that concludes number 2. Let's look at number 3. So number 3, because this is a starred question, we have to show our work. Now, in this sort of situation, they tell us that if the point 3, -7 is on the graph of the function f of x, we want to determine the coordinates of the point on the transformed function g of x equals 5/3 f of x plus 12 minus 4. So this is going to be a test of, do we know how to read function notation? So we can see that g of x is a result of transforming f of x in some way, since we see f of x right here as such. So what we see is objectively true is that there are 3 things happening to f of x to form g of x. We have this 5/3, this plus 12, and this minus 4. So what we want to do from here is interpret the influence of each of these operations on f of x, and that will tell us what to do to our coordinates in turn. So over here, because the plus 12 is within the input, or in other words, directly affecting the x values, here we know it's definitely going to be shifting left and right, but because we can't trust x's, we know that this is going to be a shift to the left by 12 units. Over here, this 5/3 is on the outside of the entire function, therefore we can say that this is affecting the y values, or in other words, it's going to be a stretch or a shrink, because here we're doing multiplication. And so since 5/3 is greater than 1, then that tells us that it's going to be a vertical stretch by a scale factor of 5/3. Because if we multiply all of our y values by 5/3, they're going to get larger and larger, therefore making our graph being pulled vertically, or in other words, like when we stretch a piece of gum. Then we have this -4 here because, once again, because it's on the outside, it's affecting our outputs, and therefore this is going to be a shift of going down 4 units. So taking our original coordinate, we just want to remember the order of operations in which these transformations happen. So what we know objectively is true is that this plus 12, or the shift to the left of 12 units, is not going to be influenced by the vertical stretch or the shift down, because these, or this operation here, only affects the x values, while these operations affect our y values. So in that case, order does matter. So let's first deal with the values of x. So we're going to take our original 3, and because we're shifting to the left, we're going to subtract 12 from our value of x. And so you don't necessarily have to do it in all in one step, as I will be doing here, but let's just follow the idea as such. So we're already done with this operation. Now we got to think, well, do we do the vertical stretch first, or is it going to be a shift down first? So according to order of operations, we always work inside out, so that's already done. And then we also work from left to right. So with that in mind, then that gives us our vertical stretch to be done first. And that's going to be multiplication of -6 times 5/3 as such. So as of now, we have 3 minus 12, which gives us -9. Now, in this case, instead of using a calculator to solve this, we can think about it in terms of two operations. Whenever we see multiplication by fractions, I will typically put very nice fractions on the test. So we can think about it as divide by denominator, multiply by numerator. So what does that mean? So -6 divided by 3 is -2, and -2 times 5 will give us -10, and that is our answer. So this is our coordinate for now. So once again, we're done with these two transformations. Now we gotta worry about the last one, which is just to shift down 4 units. And that's just straight up subtracting 4 from the y values. And that gives us our final answer of -9, -14. So for 3, -6, after performing all 3 of these transformations, it then becomes -9, -14. Okay, let's move on to the next one. Number 4. So once again, starred question tells us that we have to show work in order to earn full credit. The line with the equation 4/5 x plus 1/3 y is equal to 1 is graphed on the xy plane. What is the coordinate of the x-intercept of the line? So in this sort of situation, we just have to ask ourselves, well, what does it even mean to be a x-intercept? So by definition, x-intercept is telling us to find the value of x when y is equal to 0. So if we look at this entire equation, even though it looks scary, all we got to do is just substitute y equals 0 and find the value of x. So let's do that. So that gives us 4/5 x plus 1/3 times 0 is equal to 1. Or in other words, 4/5 x is just straight up equal to 1. And so in this sort of situation, in order to eliminate this fraction of 4/5, we have to multiply both sides of the equation by the reciprocal, which is 5/4. Because once again, any number times its reciprocal is always going to equal to 1, which is exactly what we want. We want a 1x. And that gives us our final answer, x equals 5/4. And if you want to write it using decimals, that's cool too, and that should be 1.25. Yeah. Okay, let's look at 5. So 5 we have another transformation question. So they give us the graph of some random function, h of x, but hopefully when you see this guy, you know that this is an absolute value graph. So 5a asks us, on the same set of axes, sketch the function h of x minus 3 minus 5. So what we know for sure is that, well, this expression is in terms of h of x. So what they're asking us to do is to change h of x using the transformations given to us as such. So we just got to interpret what this minus 3 means and this minus 5. So the minus 3, because that is influencing the values of x, that's going to be a shift to the right by 3 units, while the minus 5 on the outside is going to influence our y values, therefore shifting down 5 units. And so the question becomes, well, how do I shift this entire function if I don't have a computer? Well, let's see. So what we can do is like identify points that are easy to identify, or in other words, integer or whole number coordinates. So I'm just plotting a couple of points as such. And so this is very similar to when we're in Algebra 1 talking about rise over run, because what we're going to do here is we're going to take every single point that we can identify and follow the transformations that we just wrote over here, which is to shift right by 3 units and then go down by 5 units. Now, once again, because this is influencing the x values and the y values respectively, it really doesn't matter the order in which we do it because these transformations do not affect each other. So if you want to go down first and then go to the right, it will give us the same exact answer. So I'm just going to go right and then down because I already committed. Okay, so going to the right 3 units, boom, and then going down 5 units. 1, 2, 3, 4, 5. Boom, that's going to be our first point. So that's one thing that we can do as such. So we want to follow this for the other points. 3 units to the right, 5 units down, boom, that's another point. So if we continue this process, we'll see that we're going to get the same exact graph, but just shifted. The entire graph will just be shifted 3 units to the right, and, 3 units to the right, and 5 units down. Boom. As such. So I'm going to cheat a little, and I'm just going to make something up here. Boom. Alright, so that's what our graph should be looking like. So once again, we're going to take every point, go 3 units to the right, 5 units down. And so this now new graph in blue is going to be our answer for 5a. And that's it. And now for 5b, they ask us to state the range of that new function that we just graphed as such. So once again, whenever we see range, we got to think, well, what does that even mean? So range is all possible outputs, or in other words, all possible y values of a given function. And the question we should be asking ourselves is, well, where does the graph span from down to up? Because whenever we talk about domain and range, everything has to be from least to greatest. So if we're talking about the y values, we're talking about all of these values as such. Where does the graph start from lowest to highest as such? Now we see that the smallest y value in this case is going to be -3. But because we see that the arrows are going to continue the graph forever and ever in these directions, we know that the graph is going to span or continue to go upwards forever and ever, therefore reaching all of the other y values. So we can either write our answer either in interval notation or inequality notation. Either one is perfectly fine. The question didn't specify, so you get to choose. So interval notation, we have to remember that, once again, everything is from least to greatest. And the same could be said about inequality notation too. And for inequality notation, key thing here is that there are no infinities. So if we write this using interval notation, least to greatest, we have -3 towards infinity, forever and ever. So therefore that will give us bracket -3, because -3 is defined as a coordinate on the graph, comma infinity, parentheses, because there is no end to infinity, hence why we use parentheses. Now when we use inequality notation, it's in the name itself, we have to describe it using inequalities. So since we're talking about the values of y here, since y's smallest value is -3 and it could be anything above -3, we can just simply say that y is greater than or equal to -3. So either one of these answers will give us full credit on the test. Let's move on to next question, page 2. Okay, so page 2 are part 2 questions, and so key thing here is that we have to show all the work. And so any question that has a correct answer with no work will receive a maximum of 1 point. So let's look at number 6. So number 6 asks us to write the equation of a line that has a slope of negative 5 over 6, and it passes through the point of 12k, comma, negative 20k, and here they tell us that k is greater than 0 in both point slope form and slope intercept form. Oh, I accidentally wrote this. Assume that k is not equal to 0, so that's a bit redundant. Whoops. Okay. So let's just identify what we know. We know the slope is, or in other words, m is negative 5 over 6, and we have some rando point, 12k, comma, negative 20k. So with these two pieces of information, that should scream to you, well, let's start off with point slope form because it's in the name itself. And once again, if you forget what point slope form is, just remember that it's literally just the slope formula in disguise, the slope formula, and just cross multiply the values. So we should have y minus y sub 1 equals m times x minus x sub 1. So let's substitute in every piece of information that we know. So we should have y minus, in this case our value of y is negative 20k, y minus negative 20k equals negative 5/6 times x minus 12k. Now because we have this double negative situation going on, that's a little bit problematic. So let's rewrite it as y plus 20k equals negative 5/6 times x minus 12k. And so that's going to be our first answer, or specifically for point slope form as such. So if you want, you could draw like a little arrow as such. So that's our first answer. Now the next thing that we need is slope intercept form. And so if we remember, slope intercept form is commonly known as y equals mx plus b, because again we know the slope and we know the y-intercept. And so in order to get that format, we just have to isolate y from here. So let's first start off by distributing the negative 5/6 to each term. And once again, I know this looks scary, but if we remember that fractions are just two operations in disguise, then we'll be chilling. So I'm just going to keep the y plus 20k. Okay, whoops. Y plus 20k as such. And then equals, well, if we distribute the negative 5/6 to the x, that's pretty straightforward. We have just straight up negative 5/6x. But over here, well, we know that we're going to be multiplying a negative value by another negative value. So therefore, it's going to be plus. And so let's figure this out together. So ignoring the signs, we have 12k and this 5 over 6. So since k is just a variable, let's just focus on the coefficient of 12. So we have 12 divided by 6 is 2. And then 2 times 5 is 10. So therefore, our answer should be 10k. And so once again, we're not there yet because we have to isolate y. So in order to do that, we can subtract 20k on both sides, therefore giving us our final answer of y equals negative 5/6x minus 10k. And so that is going to be our slope intercept form. And that's it. Let's look at 6b. So 6b says to find all values for k such that the y-intercept is positive. Well, we know in slope-intercept form, it's obvious to see what the y-intercept is. So using our slope-intercept form, we know that the y-intercept is this entire constant as such, or in other words, negative 10k. That's our y-intercept. And so they're asking us to find when would the y-intercept become positive. And so we have to remember, by definition, positive numbers are all greater than 0. So we can set this expression greater than 0 and solve for k. And so dividing both sides by negative 10, we have to remember when working with inequalities, we have to flip the sign in order to maintain truth. So therefore that gives us k is less than 0. So in English, k is less than 0, that just means that k is a negative number. And well, does that make sense? If I substitute any negative number, whether it be a decimal, a whole number, whatever it is, if we substitute k being a negative number, negative times negative 10 is going to be a positive number, exactly what we wanted. Let's look at 7. So 7, we have the following table represents a sample of sale prices in thousands of dollars and the number of new homes available at that price in 2017. So they give us some rando table, and let's see. State the linear regression function f of p. Don't get got, y'all. F of p that estimates the number of new homes available at a specific price p and round all values to the nearest hundredth. Alright, so this is where we have to use a graphing calculator in order to write this equation, because even though, yes, it does seem like there exists some sort of pattern, that doesn't necessarily entail that's going to be a perfect linear relationship. Alright, so looking at number 7, here I'm going to go through the linear regression with y'all. So once again, on the test itself, I'm not going to have the steps written for y'all. This is something that we have to remember. So first we're going to go to stat, and then it should say edit, so we're just going to press enter. And so if we remember, if you have numbers in the columns already, we just have to use the arrow buttons to highlight the name of each list and then press clear, enter. So I'm going to do that for the other one as well. Press clear, enter. So that's how we clear our entire columns. So from here, once again, we're going to input all of our X values, or in this case, the sales price P, into L1. And then we're going to put all the values for the number of new homes available, or in other words, F of P, into L sub 2. So let's do that. So you can either use the arrow buttons to move on to the next value, or you could just press enter as such. So let's just do that real quick. I'm not advanced. Well, I think I know how to do it, but I think I'm too lazy to like speed up this part of the video. Yeah. Okay. So those are our X values, and let's input our outputs. Input our outputs. So once again, whenever we do this part of the problem, we have to be very careful with how we input our data, because the moment that you mess up one number, it screws up the entire answer. So even though your process might be correct, one number really does mess with your entire answer as a whole. So I would either recommend to be very careful and move very slow with how we input the numbers, or input the numbers and just double check to see if every one of them is correct. Okay, so once we input all of our data, we just have to see that all of the data aligns up. And so if there is an additional number in one of the lists, you're going to get some sort of error. So that means that you probably input some data wrong. So once we got this down, then we go to stat once again. And then we want to go to here, which is calc. So we're going to press the arrow button to go there. And so over here, if we look carefully, you'll see in option 4 and option 8, they both say linear regression. Either one of them is perfectly fine, but just notice the very careful differences. In the fourth one, we have ax plus b, while in the 8th one, we have a plus bx. Either one is perfectly fine as long as we substitute the correct numbers that we see on the calculator as such. So let's go to option 4. Again, you can either scroll down using your arrows and press enter, or you can just press the option number 4. And so once again, this is just confirming all of our X values were in L1, yup. All of our Y values are in L2, yup. And so therefore, we're just going to keep pressing enter until it says calculate, enter. And so this is what we should see as a result. So if we look at the question very carefully, it says to round all values to the nearest hundredth, which is 2 decimal places, 1, 2. So once again, the original the original equation is going to be the first line up here. As long as we correctly substitute our values of a and b into the equation on the first line of our calculator, then we're going to get full credit. So that's all we got to do. And then for part B, when it asks for correlation coefficient, we just have to remember that r itself is the regular correlation coefficient, and we do not look at r squared. So after doing all the calculator stuff, what we should have is f of p equals, and so in this case, because they ask us to write the equation in terms of f of p and p, that means that instead of x, we have to use p, and instead of y, we use f of p. It's just function notation. It means the same exact thing. But after the linear regression, we should have negative 0.79p plus 249.86. And so part B, they ask us to state the correlation coefficient, and we have to remember that is the value, that is the R value. So all that tells us is the strength and the direction of our linear regression. What was I saying? Oh. So state the correlation coefficient of the data to the nearest hundredth and explain what this means in the context of the problem. So on our graphing calculators, we should see that R is equal to negative 0.95. And so on the test, you don't have to write R equals, but I'm just writing it so we just remember that correlation coefficient is just the regular R, not the R squared. So whenever we have these sort of situations where it says to explain in the context of the problem, we always have to remember to include what the problem is even relating, which is the relationship between the sales price of the homes and the amount of new homes that are available. So one thing that we can say is that there exists a strong negative correlation between the sales price and the number of new homes available, or we can just talk about the relationship directly. We can say that as the sales price of the homes increase, the number of new homes available decrease. Either one of these will give us full credit on the exam, but you don't have to write both. Okay. Looking at number 8. So number 8 looks kind of crazy, but if you want to bring color and use that on the exam, you're more than welcome to. So you'll see that here we got write an equation g of x whose graph represents the indicated transformations from the function f of x equals square root of x. So f of x equals square root of x, that's our original function, and we're going to do all of these transformations to create g of x. So first things first is that we have to write g of x equals, because that's our equation and what the problem is asking for. Hello, this is future Miss Pan here to correct my massive blunder from before. So if you watched the first version of the video, I severely apologize in advance, or if you saw the wrong answer key, I am here to fix my mistake. So here we have our function f of x once again, and they're asking us to write g of x using f of x and all the transformations given to us here as such. Excuse me. Okay, so what we want to identify is which of these transformations will affect our inputs and which one will affect our outputs. So we just have to remember that all the inputs are things like the reflection over the y-axis, because that is the negation of the x values. Then we also have horizontal shrink by a scale factor of 2/5, because anything that has a horizontal, or in other words, influence on moving the graph left and right, or rather horizontal shrink or horizontal stretch is also influencing the x values. And then lastly, a translation 10 units to the right. So whenever we approach the transformations, we want to make sure that, first of all, that x itself is isolated with no coefficient, so that way we can truly identify or label whatever transformation is happening. So first, when it comes to influence of x values, we have to start off with our translations. So therefore, translation 10 units to the right. Once again, x's lie, so therefore shifting to the right by 10 units is equivalent to writing subtraction of 10 as such. And then from there, we have reflection of the y-axis and horizontal shrink by a scale factor of 2/5. So once again, every single time we're trying to manipulate the values of x in terms of a horizontal stretch or shrink, or a translation either left or right, it's always going to be the opposite of what we think that it is. So over here, even though we are shrinking the graph horizontally by multiplying by 2/5, when we see it as a function itself, what actually happens is the reciprocal of that 2/5, or in other words, 5/2. And then reflection is as is, we're negating the inputs, hence why it's underneath the square root symbol. And then so from here, then we're left with a vertical stretch, which is stretching our graph vertically as such, like stretching a piece of gum. and shifting, or in other words, a translation 5 units up. Hence why these two transformations are on the outside, because they're affecting our outputs. And so that concludes number 8. And if you have any questions, please ask. Thank you. So that concludes number 8. Let's look at number 9. It says, let P be the solution to this system. Y plus 3x equals negative 21, and 7x minus 2/3 y equals negative 22. I know y'all might be shaking in your boots by seeing this fraction, but here we got two options. We either have the option of elimination or substitution. And so what I would say in this case would maybe be easier would be substitution. Now, why exactly is that? Because if we look at the first equation, y itself does not have a coefficient other than positive 1. So that allows us to very nicely isolate that value. So let's do that first. So taking our first original equation, and isolating y by subtracting 3x on both sides gives us y equals negative 3x minus 21. And so, by substitution, once we have manipulated our first equation, we're going to take that value of y and now substitute it into the equation that we have not used yet, which is our second one over here. What was I saying? Oh, LOL. Yes. Okay, so that's what we're going to do. We're going to substitute y equals negative 3x minus 21 into our equation as such. And so once again, every time we see fractions, it's not something to freak out over. It's all about perspective. So the 7x stays the same. Now, when we're distributing the negative 2/3 to each term, because we know that we're multiplying a negative number by a negative number, we know for sure that that's going to be plus. So let's just focus on the numbers itself. So we have to remember that fractions are just simply dividing by the denominator and then multiplying by the numerator. So 3 divided by 3 is 1, and 1 times 2 gives us our answer, 2x as such. So again, we can't forget that there still is a variable there. Now once again, same logic, distributing a negative to another negative, that's going to be plus, so let's just ignore the signs for now. So now we have 21 divided by 3 is 7, and 7 times 2 is going to be 14. And that's how we get our answer. But if you still want to stick to using a calculator, there's nothing wrong with that. But instead of typing a fraction on the calculator, you could just do the division and then the multiplication. Alright, so from here, let's combine like terms. So combining the 7x and the 2x, we have 9x plus 14 equals negative 22. And to solve for x, we subtract 14 on both sides, and then dividing by 9, hence gives us x is equal to negative 4. So once we already know the value of negative 4 is x, then let's find the value of y. And so we can either use the original equation or we can use the isolated version. Either one is perfectly fine. I just used the original equation because I forgot, but either one is perfectly fine. So we have y plus 3 times negative 4 because we already know x is negative 4. Therefore giving us y is equal to negative 9, and that is our answer. Now because they ask us to find the coordinates of p, we have to express p as a coordinate, so p is negative 4 comma negative 9 in parentheses. Let's move on to the next question, number 10. Number 10, Mariel wants to see if her new Stanley Cup is worth the hype. She's created a graph to the right to keep track of the temperature of her coffee over several hours. So we see time, h, temperature as such. Okay, so 10a asks us to write the equation of the line on the graph to the right. So what we know for sure is that we're going to need a slope and a y-intercept. Unless you're writing it in point-slope form, that's cool too. But the reason why I would choose to write it in slope-intercept form is because 10b asks us to interpret the slope and the y-intercept anyways. So might as well. Alright, so over here, by definition, we have to remember y-intercept is when x is 0, or in other words, as such. That's just straight up our y-intercept, this 82. Yay! Okay. Next, when it comes to finding our slope, you can either use the slope formula by choosing 2 points, or be very vigilant and careful with how we approach using rise over run. So I'm just going to choose these 2 points and use rise over run. I'm going to start over here. So rise means that we go up and down. So in order to get to the next point, we have to go down. Now we have to analyze how much are we decreasing by. So we're starting at 80 and we're going down to 78. So we have a loss of 2. That's cool. Now when we run, that's going from left to right. In this case, we need to go to the right. So that's going to be positive. But again, we have to analyze the change, not just count the units. That's how we'll get got. So here we are starting at 1 hour and going to 2 hours. So therefore, we're only going to be increasing by 1. So even though it looks like we're moving 2 units, in reality, we're only increasing by 1. So we know slope, or in other words, m, is change in y over change in x, or rise over 1. So that gives us -2 over +1, or in other words, just -2. So that will give us our full equation. Y equals -2x plus 82. Let's look at 10b. So 10b says to interpret the slope and the y-intercept. So again, our slope in this case is -2. So we can approach this in 2 ways. We can either just have a general statement of what the slope means, or we can use the number specifically according to the question and explain what that means. So generally speaking, we know that the slope is the change in temperature over time. Y'all see that? Change in temperature over change in time. So we can just say that the slope is going to be the change in temperature per hour. Or specifically using our -2, we can say that the coffee decreases by 2 degrees Fahrenheit per hour. Either one is perfectly fine, as long as we use the units that are relevant to the problem. Next, let's talk about y-intercept. So y-intercept, again, by definition, is when x is equal to 0. So when x is equal to 0, we're talking about when the time is 0. So generally speaking, we can just say that it is the initial temperature of the coffee. But if we want to use the number itself, then we just say that this is when the starting temperature of the coffee, which is initially 82 degrees Fahrenheit. And that's number 10. Let's move on to number 11. Yay! Our fave. System of equations with 3 variables. So they ask us to algebraically solve the system given below. And so at this point, we can either choose to do elimination or substitution, whatever you like. I personally like elimination, so that's what we're going to do. So the goal is to eliminate a variable to create a system of 2 variables. So once again, what we're doing is we're taking this very large system and we're making it into a smaller equivalent system that is easy to solve. So let's analyze the coefficients of x, y, and z and see which one might be better for us. So we have x's, okay, and then we have our y's, and then we have our z's. So once again, the variable in which we choose to eliminate doesn't matter as long as the arithmetic and the algebraic manipulation is fine. And so from here, I'm personally going to choose to eliminate the y's because what we see already is that we have a positive 2y, and in order to use elimination, we want to create additive inverses. So we need a positive 2y and negative 2y's. So we can just simply multiply the first and the second equation by 2 to create those additive inverses. So that's what I'm going to choose to do here. So multiplying the first 2 equations by positive 2, and once again, we're doing this because we want to create the additive inverses of negative 2y and positive 2y. So after doing all that algebraic manipulation, our first equation is going to be 2x minus 2y plus 2z is equal to -6. And then our second equation is 4x minus 2y plus 10z is equal to 8. And then the last equation stays as it is. So once we have done this, once again, what we want to do is to combine or choose pairs of equations to combine in order to eliminate our value of y, because we want to create a smaller system once again. And so it doesn't matter which 2 equations we use as long as we use each of the equations at least once, because it has to satisfy all 3 equations simultaneously, whatever the solution is. So once again, we're eliminating y. So we see a positive 2y, so therefore we can combine the first and the last equation, as well as the second and the last equation, because this is what is going to allow us to eliminate our y's as such, since these are additive inverses. So from here, let's combine like terms, or in other words, add our two equations down vertically as such, and therefore that gives us 6x plus z is equal to -4, and then for the other one, we're going to have 8x plus 9z is equal to 10. And once again, what we have done here is we've created a system of two variables and two equations, exactly what we wanted. Because from here, now that becomes easier to solve for a variable at a time. So I'm just going to copy the two equations that we have just created as such into a system. And so from here, you can choose to use elimination or substitution, whatever floats your boat, as long as it allows us to find the values of x and z. So from here, I chose to use elimination because I like to do that. And so here we can eliminate z by multiplying the first equation by -9. And so if you chose to eliminate x, that's cool too. It really doesn't matter as long as we get the same answer at the end of the day. So multiplying the first equation by -9 hence gives us, -54x minus 9z is equal to +36, and then the second equation stays as it is. And so from here, once again, we're going to combine our two equations in order to eliminate the z's, therefore giving us, -46x is equal to +46, and that gives us our first solution, x equals -1. Yay! And so once we got our first answer, now our goal is to find the value of z. And let's do that by substituting in what we know, which is that x is equal to -1. So once again, we can choose either of the two equations to solve for z, but I'm just going to choose the first one because it looks easier. Alright, so choosing the first equation, substituting x equals -1, we have 6 times -1 plus z is equal to -4. Or in other words, -6 plus z is equal to -4, therefore giving us z is equal to 2. Yay. Alright, so we're almost done because, once again, the goal of the entire problem is to find the value of x, y, and z. Since we already know the value of x and z, at this point, all we got to do is to find y by substituting in the two values that we know. And so this is where we can go back to our original three equations, and we can choose any one of them to solve for or substitute into. And so from here, I'm going to just choose the first one because it looks easier. So we have -1 minus y plus 2 is equal to -3. After combining like terms, we have to remember, this is a very common gotcha part. Here we have a minus y. That negative stays associated with the y. So therefore, we're going to have -y plus 1 is equal to -3. Subtracting 1 on both sides gives us -y is equal to -4. Or in other words, y is equal to +4. And that's it. So therefore, our solution, we can either write it as by listing out every single variable, x equals -1, y equals 4, and z is equal to 2. Or we can write it as an ordered triple, but we have to be very careful with how we order it. It has to be x, y, and z. Or in other words, -1, 4, and 2 in parentheses. And so that concludes version 1 of the practice test. And so if you struggled with any of these problems, if you don't know, on the back I always put down where each problem is from, like what concept it's related to, and which worksheet you can refer to while studying. So if you have any questions on top of this, please